Here are solutions to homework set number 7 for ECE 111. This homework set looks at integration, topics that you cover in Math 166. Now, integration is area under the curve. You can think about it as this. If this is the money that I'm adding or subtracting from my bank account, the balance is the integral of the deposits. So the first one is assuming I start at -5. That's your integration constant. What is your balance at each time? So the area under the curve right here is 0. So I take 5, add 0 to it. Over this region, I have a triangle. Area is 1/2 base times height. The area is 1. So I add 1 to it. I go up by 1. Now in this area, I add, this area is 3, 1, 1/2. This area is 2.5. So I go up 2.5, 1, 2, and a half, right here. I add 4, 1, 2, 3, 4. Go up here. Now the area is about 1.8. There's 1.8-ish. Then it starts subtracting. When the area is negative, I come down. So this area is about -1.5. So here's 1.5. This area is 2.5. 2.5. 1, 2.5. Minus 1.5. And then the area is 0. I wind up at just a flat amount. Now, when the input is 0, the output is not 0. This is like a bank account. If you're not adding money, not subtracting money, the bank isn't supposed to lose your money. It remembers how much you have, or in this case, how much you owe. Banks are very good about that. They don't forget. So the blue curve is what you should get. Again, integral is just the area under the curve. Next problem. Next problem is using Matlab. I can do numerical integration. Now there's many different forms. This is using trapezoid rule. So if I have a function like this, and I sample it at each of these points, I know what the value is at these points right here. The area under the curve using trapezoid rule is you form these trapezoids. And the area is 1/2 of y1 plus y2, the average height, times the width. So this is a function in Matlab. Given x and dy, integrate to get y. With that, I can take functions that I don't know how to do by hand and find the answer using numerical integration. For example, here's a function, sine of x plus pi over x plus pi. Find the integral. Now when you take Math 166, you'll be able to find the integral by hand. With Matlab, even if you haven't had Math 166, you can still find the integral using numerical methods. So the first step is you input x and y into Matlab. Now call this previous function up here, integrate x and y. Then plot it. So here's y. Here's the integral of y. And when y is negative, the integral goes down. When y is positive, it goes up. Goes down, goes up, goes down. There's the integral. That's the beauty of Matlab. Even if you don't know how to find the integral by hand, as long as I can get the data into Matlab, I can find the integral using numerical methods. Another example, if I have two sine waves, one at 1.5 radians per second, one at 15, that would be the blue curve. The integral is the red curve. Same procedure. Put x and y into Matlab, do numerical integration, and plot it. Again, note that I don't have to know how to find the integral by hand. If I can get it into Matlab, I can find the integral by numerical methods. In addition, typically students really like differentiation. They hate integration when they take the Calc 1, Calc 2. In practice, we hate differentiation and we like integration. And this is one reason. Noise tends to be at high frequencies. Differentiation amplifies noise, something we saw last week. integration cleans up noise. So integration, kind of like in practice, it cleans up your signals. Problem 4 is let's do some animation in Matlab. So here's one application of integration. I can do animation. For example, this is a bouncing ball. I think it's a little bit bigger. Matlab is not designed for animation, but actually does it really well. So here's a bouncing ball. What it's doing is the acceleration is 9.8 meters per second squared in the minus y direction. What I'm going to do is, if I know the acceleration, integrate once, I get velocity. Integrate second time, I get position. Once I have position, plot it. In addition, I'm going to bounce off the ground. If I ever go negative, I'm going to change the direction of the velocity, bounce up, and this is what that looks like. So I go negative right there, bounce, change the direction of velocity, bounces up. I've got a bouncing ball. Okay, Matlab is not really designed for animation, but really does a pretty good job at it. So here's the challenge. I want to run the simulation until I hit the ground twice. So if y ever goes negative, I switch the sign and count. Keep going until I hit the second bounce. So to run that, there's the first bounce, second bounce. Once this is done, I can tell you where I hit the ground. First bounce, second bounce, and I hit the ground going over to the command window. Okay, next problem. Let's have it hit a target at 10. So to do that, that's a function equals 0. Let's come up with two initial guesses. I'm going to start out that the initial velocity is 1 and see where I hit. So I'll get this over here. Here's my initial velocity. First bounce. Second bounce. So 1 gave you 2.46, or the error, 10 minus x, was 7.54. So there's my first guess. Here's x, here's the error. 1 had an error of 7.54. Let's try x equals 2. It's actually x prime. X prime is 2. Run the simulation. First bounce. Second bounce. And the error is 10 minus x, 5.08. So what should the velocity be so that the error is 0? To calculate that, I've got the slope. The slope is 7.54 minus 5.08. Change in y. Change in x is 2 minus 1. That's the sensitivity. Let's see, let's take the first point. Times the initial error, 7.54. Let's do that in Matlab. Yeah, actually, let's use a calculator. So 7.54 minus 5.08 over 2 minus 1 times 7.54. That's how much I want to change. I got that backwards. 2 minus 1 over that. Now check out the units. The units need to cancel. So this is y divided by y. Y's cancel, there's x. X needs to change by 3.06. So my initial velocity, corresponding to this one, was 1 meter per second. I need to increase it by 3.06. So my next guess ought to be 4.065. That's Newton's method, or California method. Make this 4.065. Run it. First bounce. Second bounce. And I hit at 9.999. Basically nailed it. California method is a pretty good method for finding a function equals 0. I can guess again, but if you're willing to do some calculations, I can save a lot of time. Here on the third guess, I nailed it. Finally, the last problem is a shoot game. So the shoot game is I have this M file. I lob a tennis ball in the air at the initial speed, angle, and there's the target I want to hit. Find the speed and the angle to hit the target. So the way you call it is from the command window. I can say shoot. Let's have the target is 50 plus 50 times rand. Here's my target. Let's do shoot. I'm going to launch a tennis ball at 40-degree angle at 20 meters per second at a 40-degree angle, and my target's at 90.73. So here it launches the tennis ball, and I missed the target. I missed it by 52.61. Problem 6 says hit the target using trial and error. Okay, so 20 was too low. Let's try 30 meters per second. Launch a tennis ball, and I was closer. Let's try 32 meters per second. Okay, better. Let's try 35 meters per second. Too much. Let's try 33.5. With trial and error, I can eventually get there. That's one way to do it. There are better ways. Problem 7 says repeat using your favorite method, California method or Newton's method. So if I do California method, I first take a guess. Let's try 20 meters per second. Let's do it this way. X1 is 20. Y1 is shoot of X1, 40-degree angle. Launch a tennis ball with that initial condition. And I missed. Let's try X2 is 25. Find the error with that one. Now using California method, my next guess will be based upon those two. Interpolate. Draw a straight line to force y to 0. So that's going to be my x3 is x1 minus, change in x, x2 minus x1 over y2 minus y1 times y1. And you can use 1 or 2, you just have to be consistent. So here's the slope, the sensitivity. And to get it, the formula right, check the units. These are x's, x in the numerator, times y divided by y. The y's cancel, my units are x. So there's my next guess. Let's try it. Here's y3. Launch the tennis ball. And pretty darn close. Well, given the last two guesses, I can interpolate, find the next guess. Guess 4 will be x3, 3, 2, 3, 2, 3. Again, I just have to be consistent. If that's x3, that's also y3. That's what I should try for my next guess. Launch tennis ball. Just about nailed it. So if you're willing to do some calculations, I can solve problems a whole lot faster than trial and error, and Matlab is a really good way to do that. And the simulation we're using is using numerical integration. I launch a tennis ball, just like a bouncing ball. I know its velocity in the x direction, y direction. I know the acceleration, 9.8 meters per second in the minus y direction. Integrate once, I get velocity. Integrate twice, I get position. Plot the position. Repeat every 10 milliseconds. That is homework set number 7 for ECE 111. Stuff that you're going to counter when you take Math 166 using integration, and solving such problems using numerical methods and Matlab. Basically, Matlab is a really useful program. You can solve a lot of problems with Matlab.